Data Skeptic mini-episodes provide high-level descriptions of key concepts related to data science and skepticism. Today's topic is the CAP Theorem.
Linda, do you know what a phone tree is?
Oh yeah, I meant to talk to you about this.
Yeah.
I actually don't know, and you made me act like I do. So you want me to just play along?
No, we can talk about the difference in our ages then. But you have to ask me questions about how it works.
Okay. So let's start over.
So Linda, do you know what a phone tree is?
You know, it's funny. I don't.
You didn't. You didn't have a phone tree when you were in elementary school?
No, I actually looked it up because you mentioned this word to me.
Yeah.
So I looked it up. I'm not going to explain it. I'm going to wait for you to explain it. But I thought a phone tree was something like a family tree. So it's like you have
Well,
a diagram
a little bit
of everyone's phone numbers, and I don't know.
So wait, did we just find like the dividing line between me being older than you? Is it phone trees? Is that where the line was crossed technology-wise?
Well, maybe you could tell me more about why you know what a phone tree is and what it is.
You're not that much younger than me. We had one when I was in elementary school. Oh, it's because...
So what is it?
If your school needed to get some information out, like let's say there was a snow day, they had to alert everybody. It would start with presumably the principal, right? And the principal would have the top, he would be the root of the tree, the top. And then he'd have to call, like, let's say 5 people. And then they would call 5 other people, and they would call 5 people. And this way, everyone got the call that, school's canceled.
So everyone's required to call 5 people or something? Or
something
a set
like that,
number
yeah.
of people?
I mean, I feel like people volunteered. And if you didn't volunteer, you got just at the edge where you were only a consumer. You just got informed. But yeah, my mother was very involved in this part. She was she did her volunteer participation. She called and passed along.
So you remember your mother distinctly making phone calls?
As I recall, she was very highly ranked. She had like a principal. You know what an Erdos number is?
No.
All right, never mind. You know what a bacon number is?
Bacon? Like the food?
Yeah.
No.
Okay, well, these are distractions. It's like how far you are from Kevin Bacon if you were in a movie from him.
Oh, that.
Erdos number is the same thing for mathematicians. She was like a 2. She was like really close to the principal, maybe even a 1.
And how old were you when you
Elementary school, like between kindergarten and probably 6th grade at least, maybe 8th grade. I don't think we had one in high school.
You know, I'm trying to think back. I grew up in Florida, so if there was like a hurricane, they would cancel school sometimes. That is the only chance we would get cancellation of school. But that, you just watch the news and they would flash all the counties or school districts at the bottom of the TV. So you just sat there and stared at the TV. We didn't need a phone tree.
It was on TV for us too, but that was like inefficient. What if you needed to know now? Because it would only cycle through every once in a while.
Oh, no, it was like cycling through once every 10 minutes or something.
Well, maybe you didn't have as many school districts.
Yeah, that must be it. Chicago must have like significantly more because bigger population.
Well, yeah, it covers all the whole, it covers the North Burbs, the South, everywhere.
And then I remember when I was on a soccer team, people would call us and like, let's say there was like a tryout or a game. They would call to like remind and confirm, like, is your child going to this game? And they would like talk to your parents. Just to make sure that they had enough kids for a game.
Yeah.
But I don't know if it was phone tree. I think it was just the coach or the assistant coach. It wasn't, because you only have to call how many people there are on a soccer team. I don't even know, like 13 or 20. There's a range of kids. But.
So why do we even need the phone tree? Why wouldn't everyone just call the school directly?
Yeah, I don't know. Why?
Well, because then the phone would be ringing off the hook. There's like 1,000 families potentially all trying to get this information. And if there's like one phone line and one like administrative assistant, they can't handle that.
Oh, I thought it was going to be like an automated message. Like, hello, you've reached the school district of whatever. We are canceled for June 30th or whatever.
Yeah, so I guess that's a good way. That's probably how it works today. You check the website, and that's because the website, if they've scaled it out right, it can handle a heavy load of traffic, right? 1,000 people can all look at it at once, and it's fine. And they all more or less see the same information. But if you only had one phone line and a person had to answer, then they couldn't take all those calls. So that's what we would call a low availability, you see, because there was a chance you would get a busy signal. So it's not always available. Are you with me on A? That's going to be the A of the CAP theorem.
The A. What's the A?
Availability.
Oh, availability.
Yeah.
Okay, so I'm going to define availability as like bandwidth, its capacity.
Essentially, it's like capacity. If there's only one person answering the phone, but if you did get through, you called back enough times, and finally you didn't get the busy signal and someone answered the phone, do you think the information they gave you would be reliable, up to date?
Should be.
Yeah, it should be, right? Because that's the official source. That's the single source of truth. While this situation has very low availability, it actually has high consistency. And that's the C of the CAP theorem.
Consistency as in everyone's being told
the same information.
Same thing.
Yeah.
Earlier we were saying CAP theorem.
Yep.
And you said you're afraid someone was going to mishear it as cat theorem.
Yeah, I asked you to re-enunciate the intro, yeah.
So, there's the, what's that called when you play that game? Oh, telephone, yes.
Yeah, I know.
Child.
I thought you were going to ask me what the P meant.
Well, what is the P?
Partition tolerant. And that's the one that has the hardest definition to give in a sort of vernacular way. But so people who really know what it is, we'll pick a little bit on this explanation. But just think of it as if we have to split the work up, can that be done? So like, let's say you had 2 phone lines and 2 secretaries answering the phone. If one of them suddenly lost power, could the other one pick up all the work?
Probably not. I don't think so.
So if they couldn't, if that person was like, I'm union, I'm going on my break, then no, that would not be partition tolerant. But if on the other hand, the person was like, well, they're going to get a busy signal more, but I'll be here, and I have the information, then it is partition tolerant. But what if, let's say, certain classes, this wouldn't happen, but certain classes like 6th grade, that had a snow day, but 5th grade did not. And if one of the secretaries only specialized in some of the grades and the other secretary specialized in the others, then if one of them got knocked out, then the information would no longer be available. That would not be partition tolerant.
Yeah.
So partition tolerant is about if the system still holds all the information, even if part of it goes down. Now, this CAP theorem becomes very important in computer systems when you have to grow into the big data realm, or at least outside of one node, because the CAP theorem tells us you cannot have all 3 of these things. Your system cannot be consistent, available, and partition tolerant. So sometimes it's described as a trade-off, we'll accept less availability for more consistency. And to a certain degree, that's true. There are trade-offs you can take advantage of, but you could also have a system that just degrades in both this respect. So this is a way in which you will frame your data store. If you're going to store data in a clustered computing scenario or adopt some vendor's technology, you'd want to know how it works in all these situations. So maybe let's go through the phone tree. So what if you were down the chain on the phone tree? You were 6 or 7 generations away from the principal, and you were trying to leave the house, and you need this information now. So you called up the person who's supposed to call you. Do you think they will have the information or not?
No, you have to wait.
Yeah. So it's not consistent in a sense, because you might call them and they would say, as far as we know, school is not canceled. But then 2 minutes later, they get the call and they're like, oh no, actually it was canceled. Sorry. Uh-huh. So that would be a inconsistency in the phone tree. But what about availability?
Well, they're available.
Depending on how they're paired off, then yeah, people might always be available to call the other person without busy signals. But also you could say the tree overlaps. There are 3 people who might call you, and then you're sure to get the message, and you're more sure to have someone you can call and ask as well. And then partition tolerant would be if one family was on vacation, then does the phone tree still work?
Yeah, I don't know. Let's think about that.
Now you have a node that is dropped out of the system. They're not going to receive the update, nor will they pass it along or be available to be queried for this information.
Mm-hmm.
Unless you set up redundancy, would not be partition tolerant. You would have to be if they don't answer, then you call your backup person, something like that.
Yeah, I guess they would just have to give you 2 numbers. If you don't get a phone call, call this number. So there's just one person that's backup.
Mm-hmm.
And hopefully there's not too many blackouts, I guess.
But as you add those redundancies in, then it becomes harder to be consistent and available.
So again, summarize, what is the CAP theorem?
The CAP theorem tells us that any system of record, something you want to get information out of and store information in, it cannot be all 3 of these things: consistent, available, and partition tolerant. You have to have some compromise between each of them. And you can be perfect at one of them, maybe even 2, But if you're like perfect at one, you're certainly not perfect at the others. So there's a few more details here we could get into, but it's a mini episode, and I think we've covered the high-level bits of it. Thanks as always for joining me, Linda.
Thank you.
And until next time, I want to remind everyone to keep thinking skeptically of and with data.
For more on this episode, visit dataskeptic.com. If you enjoyed the show, please give us a review on iTunes or Stitcher.